Greetings everyone. I welcome you to yet another lecture of circuits and systems. In today's lecture, we'll be seeing Laplace transform. So we'll be going with the basics of Laplace transform of basic signals and waveform synthesis. So I find that harder I work, more luck I seems to have. So my hard work and my luck are interdependent. The more hard work I do, more luckier I'm going to get. So with this inspirational quote, let's start with today's lecture. So we have Laplace transform. So what does a transform do? A transform transforms a time domain signal into a frequency domain signal, and an inverse transform transforms a frequency domain signal into a time domain signal. So my Laplace transform is defined as for x of s from minus infinity to plus infinity, x of t e raised to the power minus st dt, where s is nothing but sigma plus j omega, where sigma is the real part and omega is the imaginary part of this s. Now, if my xt is a causal signal, that is, my xt is equal to 0 for t less than 0, then I have a unilateral Laplace transform, which is x of s starts from 0, goes till infinity, x of t e raised to the power minus st dt. So these are the two basics form of my Laplace transform. In this course, of circuits and system, we'll be preferring and we'll be having only unilateral Laplace transform. So for a basic signal, these are the few Laplace transform which has been calculated. So you don't have to calculate it. In exam, nobody is going to ask you for calculating these Laplace transform. And even if they ask, you can always calculate it using the formula. But you should remember the Laplace transform of del t, that is your impulse signal. Impulse signal is 1. Ut, that is your unit step, is 1 by s. E raised to the power minus at, that is exponentially decaying signal, is 1 over s plus a. So these are the Laplace transform which you should remember. T, that is unit ramp, is 1 over s square. Then t at is 1 over s plus a square. Then we have for sine omega t, you'll be having circuits having input as sine omega t, cos omega t, unit step response, unit impulse response, unit ramp response, and the last two. So you need to remember directly the outcome of these Laplace transforms. So you can just take a screenshot and try to remember and try to learn all these Laplace transform results. So with this, we are moving to the properties of Laplace transform. So we need to remember, we need to know the most important property which helps us in waveform synthesis is linearity. So what is linearity? So if we have a waveform, we have a bigger waveform, we divide that waveform into sections, and if we calculate the Laplace transform for each section, then by adding, it will give me the Laplace transform of the complete waveform. This is achieved because my Laplace transform is a linear transform. Then the most important property for calculating the waveform synthesis is time shift. So if I have a shift in time, let us say f of t minus a, my signal has shifted with t minus a, u of t minus a, this is going to give me e raised to the power same shift in terms of frequency multiplied by the Laplace transform of this f of t. Okay, so then this property, differentiation property, this you'll be having you'll be utilizing this property when you'll be going for circuit evaluation. So a circuit with one energy storing element will have a differential equation of order 1. So you'll be requiring this. And a circuit with two energy storing element, for example, an RLC circuit will always have its function in terms of order 2. Then the most important property in terms of excuse me, in terms of waveform synthesis is time periodicity. Now this property will help us finding the waveform, finding the Laplace transform of a periodic waveform. And then the two favorite properties of examiner to be asked, initial value and final value theorem of Laplace transform. So these are the properties which you should remember. So out of these, this and this time periodicity, we'll be seeing it in this lecture itself when we'll be going for waveform synthesis. So let's go for the waveform synthesis. Now, all these four waveforms, 1, 2 and 2 more we'll be discussing, are the favorite waveforms of examiners, and this you'll find that one of these will be there in your exam. So let us start with the first one. So in the first waveform, they have asked us to find out f of s of the first waveform. So we have already gone through with the synthesis of the waveform chapter. So if you haven't seen it, I'll provide the link in the description. You must watch that video first before going into this one, because here we'll be straight away writing the equation in the very, what we can say, I'll not be explaining the equation. So let us write for f of t. So f of t, my waveform will be 5 ut plus 5 u of t minus 1 plus 5 u of t minus 2. Then we have minus 5 u of t minus 3. Then minus 5 u of t minus 4. Then we have minus 5 u of t minus 5. So this is the waveform. See, for details, you can always go and watch the other video so that you know the details. Anyways, if you still want to know what I've done for every point where my waveform is experiencing a change. See, at 0, it is changing from 0 to plus 5. So plus 5 ut. At 1, it is changing from 5 to 10. So plus 5 u of t minus 1. From 2 u of 10 to 15 plus 5 u of t minus 2. At 3, it is dipping down by 5. So minus 5 u of t minus 3. Here there is a dip, minus 5 u of t minus 4, and similarly in this way. Now simply you just have to convert u of t into the Laplace transform. So I'll just write down u of t, the Laplace transform of u of t is 1 by s, and u of t minus a is e raised to the power minus as over s. So utilizing this, so I'll take 5 common, and I can take 1 by s also common, because in every ut 1 by s would be there. So it would be 1 plus e raised to the power minus s plus e raised to the power minus 2s minus e raised to the power minus 3s minus e raised to the power minus 4s minus e raised to the power minus 5s. So this is the Laplace transform of the given waveform. Is it correct? So moving to the other one. Now this is examiner's favorite, number 2. Now here we have a ramp signal or triangular wave. So for ramp signal, we always try to calculate what are the changes. So we have changes over here, and over here. So here my slope is changing from 0 to plus 3. So there is a change of 1 over here, 3 over here. So it's a plus 3. From here till here, there is a change of slope is minus 3. So at 0, that is delta at 0, there will be change from 0 to plus 3. So final slope is 3, minus 0 is 3. Then delta 1, I'm writing the change over here. It would be minus 3, it would be minus 6. delta 2, it will be 0, minus 3, it would be 3. So I've got all the deltas. So my ft will look like 3 RT plus, or rather minus 6 R T minus 1 plus 3 R T minus 2. So this is my delta ft for this complete waveform. Now I'll just represent this waveform in terms of t and ut. So can I take 3 common? Yes, I can take 3 common. So this is t ut minus 3 t minus 1 u of t minus 1 plus t minus 2 u of t minus 2. Now 3 common. So tut 1 by s square minus 3. There is a shift of 1, e raised to the power minus s over s square plus there is a shift of 2. So e raised to the power minus 2s over s square. So I'll take s square common. So it would be 3s square 1 minus 3, or rather 2. It would be 2, right? So 2 e raised to the power minus s plus e raised to the power minus 2s. So this is my final answer. Is it clear? So if you want to see, for t, my Laplace transform is 1 upon s square. For t minus a, u of t minus a, my Laplace transform will be e raised to the power minus as over s square. So I've used these two to analyze the complete waveform. So this is how we analyze the Laplace transform of the triangular wave and a unit step. Now moving ahead, now the most important ones, waveform synthesis of a periodic waveform. So before moving into this, I'll be telling you the property. So the property is, it says for f, if s, if it's a periodic waveform, then its Laplace transform would be f1s over 1 minus e raised to the power minus s capital T. Now this capital T is nothing but my time period. Okay. Now if you see this waveform, then it starts from 0, moves till 2, ends at this and comes at here. So this complete set of waveform is repeated after every interval. So the time period for this repetition, capital T, is 2. So for 2 time periods, the waveform remains same and it repeats after that. So I have got the value of capital T to be 2. Now I need to calculate F1s. For F1s, I need to know F1t. So my F1t, again, start finding out the changes. So the first change is slope was 0 over here, slope is 2 over here. So it would be 2 times of RT. Now at this point, it has just dipped with the amplitude of 2. So it would be minus 2 u of t minus 1. And at the very same point, if you see, the slope was rising by plus 2. Now the slope is 0. So final slope is minus 2. It would be minus 2r t minus 1. So this is it. So this is what we have got as f of f1t. Now the time period has already been decided over here. So now I just need to write it in the form of ut and t. So it would be 2, I can take common. So it would be t ut minus u of t minus 1 minus t minus 1 u of t minus 1. So it would be 2 1 over s square minus e raised to the power minus s over s minus e raised to the power minus s over s square. So S can be taken common, or rather even if you want to leave it, you can leave it like this. So this becomes your F1S. So your F of S will be 2 into 1 over S square, or rather e raised to the power, okay, 1 over S square. Let's just write it clearly, 1 over S square minus e raised to the power minus S over S square minus e raised to the power minus S over S multiply by 1 over, with this property we have got 1 minus e raised to the power minus S2. So this is my F of S. You can leave it here. If you want, you can further simplify it. Now, moving to the another examiner's favorite question. So, in this waveform, if you see, this waveform starts from 0, starts from 2, goes till here, and at 4, we'll consider this waveform is ended. So, we have got the time period to be t is equals to 4. So, my F1, Fs, or in this case, it would be Is, would be I1s over 1 minus e raised to the power minus S4. Now, what is I1s? So, for I1s, I need to know I1t. Now, we have already seen the synthesis of this waveform in the previous video, as I've already told you. So I'll just write down till this point, till this point. Okay. So at the first point, it would be minus 2 ut. There is a change of minus 2 plus 2 rt. Then there is a change of slope. It would be minus 4 r of t minus 2. Now at this 4 point, now comes the interesting change. Now if you see, I just have to end this waveform over here. Now if I have to end this waveform, now consider I've started this waveform from here, gone till here, and now I'll end this waveform at this point. So at 4, there's an interesting thing happening. The waveform will go back to 0. So it would be plus 2 u of t minus 4. Also, there's a change of slope. So which slope which was going at minus 2 will end at 0. So final slope is 0. 0 of minus and minus 2 will give me plus 2 r t minus 4. So this is my I1t. Okay. Now I've got I1t. Let's calculate I1 is. So I1t can be represented in the form of UTs and T and UT. So it would be minus 2 UT plus 2 TUT, then minus 4 T minus 2 U of T minus 2 plus 2 U of T minus 4 plus 2 T minus 4 U of T minus 4. So this can be written as minus 2s plus 2s square minus 4 e raised to the power minus 2s over s square plus 2 e raised to the power minus 4s over s plus 2 e raised to the power minus 4s over s square. Now combining the terms of s with each other and simplifying the equation for s square. So I'm taking 2s square common. So 1 minus 2 e raised to the power minus 2s plus e raised to the power minus 4s minus, I've taken minus 2s common. So it would be 1 minus, we have got over here e raised to the power minus 4s. So this becomes my I1s. So now I've got my I1s, multiply it with 1 by, so my Is would be I1s divided by 1 minus e raised to the power minus s4. So this is how we calculate the waveform synthesis in the form of Laplace for a periodic waveform. So you need to remember this formula So you need to remember this formula, and you need to remember to how to calculate time period. Calculate for the first time period, calculate I1t or F1t, whatever is asked. And then for complete IS, just divide I1t by 1 by e raised to the power minus st. So remember this thing, every little thing we do leads to a bigger thing. So your little efforts will combine and form a bigger thing, and you'll surely get good marks in your examination. So keep liking, sharing, and subscribing the channel, and it will help your universe to grow and expand. Thank you and all the best.